Hello, welcome to our introduction to graphing logarithms in Mr. Schenken's 11th grade advanced algebra class. So we have our standard for the day. You can pause and read that if you would like to. Our learning objective, however, I can recognize the horizontal and vertical shifts in a logarithm function. So we're going to go get into that. We did exponentials before. Now we're going to move on to our logarithms. So let's get going. So our base logarithm, we have this model here. We got a log base b of x minus d plus c. Our a is going to be amplitude, our b is going to be our base. Our c and d are what we're going to really focus on today. That's why they're in green. Our c is going to be our vertical shift, and our d is going to be our horizontal shift. Pay close attention to that minus sign because that can get you tripped up with your signs. If you're coming back from our factoring, you remember if you see a minus sign in there, you just think the opposite of whatever the value, the trailing term behind your x is. If you want to just think about it matching up, you see x minus, what's remaining is your d. So in this example here, over here, we got log of 4, x minus 2 plus 3. And our a is going to be 1. And we're going to generally have, because right out here, that missing number right there, if you don't have a number, it's always going to be 1. So right there, we have a as 1, and we're going to keep with a as 1 for our class. We're going to just keep our logarithms, that leading value of 1. When we get to pre-cal, we can start looking at different amplitudes, but for our class, we're going to stick with a equals 1. And we're going to go with keep on going through our alphabet. Our B right here, B is our base. You see it modeled on over there. It's going to be what's in subscript. B is 4. Our C is 3 because we're looking at that end tack. Stack it on there at the end. Then we have our D. Remember what we were talking about, that x minus D, x minus 2. Our D is going to be 2. So we're going to start with our vertical shifts. We're going to look at some examples there. Or Oh, sorry. Actually going to work on finding our C's and D's, then we'll get to our vertical shift. Sorry for that. So looking at our finding C and D, and we're going to keep our model generally right up here or somewhere on our screen so we can have good reference to that. That's going to be something you want to write down if you're taking notes. So our vertical. So looking at our example right here, f of x is equal to log of x base 2 plus 4. If we map up what our change from our parent function is, so we're looking at that c, and so we're looking at these on the inside, c's on the outside. So we know we have that c right there on that outside, or matching it up right here, we got our c of 4. So we're going to move 4 units up because our verticals are always going to deal with our ups and our downs, and then our horizontals are going to go to the right and left. So we got a plus 4 moving us up 4 units. And right now, the units moving up and down is going to get more clear when we see our visual example. But what I really want you to make sure you can do is identify that C and that D. So let's look at another vertical example. We got f of x equals the log of x base 8 minus 3. So before we had a plus, this time we have a minus. If we look over here, it calls for a plus. So that C on the outside of here, outside of your argument, is going to be that -3. We're going to go 3 units down. So remember, if we got a positive, we're moving up for the vertical, and if we got a negative, we're moving down. So let's look at our horizontal. So now we're going to be looking inside of that, change inside of that argument right there. So we've got log of x minus 4 base 2. We're going to identify our d. We look up here, it's at x minus d. We got x minus 4. And again, we got that 4 units to the right because remember our positive horizontal shifts move to the right, our negatives move to the left. All right. Now let's look at our next example. We got f of x equals the log of x plus 3 base 8. Look over here. We got that minus. We got a plus here, so we're going to have to change our sign. We change it to a -3. That -3 implies that we're going to be moving 3 units to the left. All right, let's bring these two together for some combos. We got f of x equals the log of x minus 2 base 2 minus 4. We pair it up with our model right there. You can see that our c, we got the positive, the negative. So our c is going to be -4. That's going to be 4 units down. We look towards our inside right here. We got that d. We got x minus d, x minus 2. That direct parallel. We're going to have a d of 2. So we're going to have 2 units to the right. Let's look at one more combo, and then we're going to move on to some visual for our visual learners here. We have f of x equals log of x plus 1 base 8 plus 7. So again, on the outside of the argument again, the inside. Moving a little bit too fast. We got the log of x plus 7. We got plus c here, so we're going to be moving 7 units to the right. Our d, if you want to identify that, we got another plus sign in here, so we're going to change that to a negative sign. We have our d equals -1, and that's going to be 4 units to the left. Okay. Our vertical shift. So now we're going to actually see visually what it is. If we look over here, we got that log of 4x is our red function, and log of 4x plus 2 is our blue function. We have a model here. Let's look at it. So we got log of x plus 4, and it's going to say 2 units up. So I've identified a couple points, and these points will become more familiar when we get to our next lesson on graphing logarithms. Well, I'll tell you how to find those. But for now, just look at the patterns of change. So we go 1, 0 to 1, 2. So our x didn't change. Our y's did, our output. Our vertical shifts affect our outputs or our y values. So we say we go from 1, 0, we add 2 units because of our c being 2. We go 2 units up, we go to 1, 2. We've got this point 4, 1. And in this very similar fashion, we can start going from 4, 1, we say plus 2 to our y values, our outputs, and we go up to 4, comma 3. So you can see visually where that red line moved all up to the blue line. So this, again, we got our base function here, and then we have our vertical shift of 2 units up as our blue line. For horizontal shift, this one's a little bit harder to see, but we can still get there. All right, so we got the base function of log of 4x in the red right here. And then we have log of x minus 2 base 4 in the blue right here. If we do our math, we see that we have x minus d, x minus 2. So our d is going to equal to 2. And we know that a positive d moves everything to the right. So we can see these points 1, 0 being shifted over to 3, 0. 6, 4, 1 being shifted over to 6, 1 because we are moving along our horizontal. That's going to be our x's. So we can see that the x value of our points have been moved. And just like before, when we did our verticals and our horizontal identifications, then we did a combination. So let's look at the two functions. So we went up and then we went out. Let's look at what happens when we have both. We have our base function log of x, and then we have log of x minus 2 plus 2. So coming over here, we know that we got a C of 2 looking on that outside right here. We've got a D of 2 looking on the inside of our argument. Those minus signs matching up. We got a positive 2. So we can see our values going from 1, 0 to 3, 2 because we have our C moving our X 1, 2 points over, and then moving our Y up 1, 2 points over. Okay.